We have Hongwei Zhang with University of Iowa and Jiri Power and Jiri Skopek.
So here I'm going to share share one project that we just get started. It's a project about rural broadband technology. So this is let me see. This is a part of the this ARA project is targeting building a wireless living lab for smart and connected rural communities. It's part of the National Science Foundation Platforms for Advanced Wireless Research program that's looking to develop 4 platforms, 4 field deployed at-scale platforms for driving research, education, innovation in the future generational wireless networks. So there are 3 projects that's actually mostly in the urban and suburban areas. For example, there's a Cosmos in New York City, Powder in Salt Lake City, and then AirPower in the Research Triangle. So ARA is the latest power project that just get started back in June. The focus of ARA is on rural broadband. The other power project focused on the other aspect of the future wireless, future generation of wireless. ARA is the only project focused on rural broadband. So we have heard a lot of the discussion about rural broadband. Also this morning, Greg gave a very good talk about what they are doing there using ARA-Stat. For the ARA project itself, it also has a huge focus on looking at what are the the missing elements as far as technology is concerned, right? We know we have fiber, Wi-Fi 6, 5G, Neo Satcom, but what are the other missing components that need to be there if you want to reduce the cost of rural broadband by a factor of 10 or more, so that we can make rural broadband as affordable as urban broadband. So that's one of the primary objectives for the ARA project. Related to that, there's also, as we have discussed extensively here in the workshop, how do we not only providing connectivity broadband to the rural communities, but also look at the unique needs of rural industries in farms, factories, and so on. So those are the 2 primary objectives as we plan the ARA project and also as we're executing in the coming years. So in what follows, I'm going to give a very high-level overview about the ARA deployment and the planned activities. So the deployment of ARA consists of 2 major layers of infrastructures. One is the wireless backhaul infrastructure, which we call the ARA Hall. So ARA Hall is going to be deployed in central Iowa, spanning cities like 6 rural towns plus some research farms in that's run by ISU, Iowa State University, spanning an area of diameter over 36 miles. For example, from the city of Boone to the state center, a good area, a large area in the rural central Iowa. So the link that's shown here, these are actually not fibers. There will be those high capacity, long distance wireless backhaul solutions that I'll touch on briefly, shortly. And then at each of these sites, we would also have access network so that we can integrate the the farm, the tractors, other ag machines with sensors, as well as community facilities to the backhaul. And then around the city of Ames, we would have a denser deployment covering several additional livestock and crop farms, as well as the ISU Research Park, where you would see the research centers of companies such as John Deere, Collins Aerospace, Vermeer, doing active research there. We would also have a Helikite, which is also an ARA platform. It's similar to the ARA-Stat, but it also tries to leverage the airlift, the lift power of the air. So, but at a high level, it's kind of similar to the ARA-Stat that Greg mentioned earlier. So just a little bit more about some of the specific platforms for the long distance high capacity backhaul, the ARA Hall infrastructure. It's going to use a diverse set of terrestrial and satellite communication platforms. On the terrestrial part, it's going to cover frequencies all the way from optical to millimeter wave down to microwave. For example, we will develop a new free space optical platform that can potentially offer capacity over 160 gig BPS over a distance of about 10 miles without having to rely on any ground buried fibers. Long distance wireless backhaul has been used for a long time, but one of the main drawbacks right now is one, lack of high capacity. Second is the lack of resiliency. So therefore, we are going to also enable research and innovation that's going to leverage all this diverse set of resources to provision robust, high capacity wireless backhaul links as part of the project. On the access network, this is where you also see those 5G and beyond type of research platforms, including the multi-antenna massive MIMO platform at low frequency band, which can offer capacity over 100 Mbps at large cell radius. And we also include some other cards, 5G platforms, also other software-defined radio platforms, so that you can experiment with solutions that are all the way from the file layer up to the application. So it's going to enable a wide range of research, for example, including how do we enable dynamic spectrum sharing, because that's actually one of the canonical challenges for rural telcos to run wireless-based services traditionally. So hopefully with this, this infrastructure, we can enable research that can bring more, make more spectrum that's going to be dynamically available over time. So, as a wireless researcher the ARA has a huge focus on the next generation of wireless technologies that can serve enabler for the next phase of rural broadband. But in the meantime, we would also have, it's also going to enable as a living lab, we're also going to support the application research in terms of the new application that can be enabled by high capacity wireless connectivity everywhere in the rural farms and communities. These include agriculture automation, also rural education, I think by using extended reality to enrich the learning experience, connecting ultimate transportations as well as public safety. Those are some of the key focus areas that we're going to look at in the coming years. So one thing I want to just highlight here is that we are still at the very early phase of this exploration, right? Because of that, one of the main goals for the project is to help drive innovation in 5G and beyond, those kind of broadband technologies. At the same time, given that we don't have those capabilities today, and many of the applications are still at the early phase of the exploration, there's also the opportunity and need for innovation at the application space. And given that, we are still at the, both for wireless and technology, they're still at the early phase of the development, there's a need for co-design, right? Kind of jointly optimize their performance so that we can meet the expectation of the end users. So this need for co-design, also need for wireless innovation also make broadband as an innovation opportunity in addition to as a service to the communities, right? I think traditionally when we think about broadband, we'll probably, especially in the rural communities, we probably think more about how we can take whatever technology developed elsewhere and to use it in our communities. But I think as we think about the continuous technology evolution and the opportunity out there and the need for new broadband technology, I feel broadband, another avenue we can and should look at is how we can use this as a innovation economic development opportunity itself, other than just treat it as a service to provide. So ARA as a project is a community focused project, right? So the goal is to develop this at-scale living lab so that it can serve the broad research, education, and innovation communities. So therefore, one of the main focus for the project is to look at activities that can leverage this national infrastructure that will be stood up in the coming 3 years to really how to drive the innovation across both wireless application and their adoptions. So we are looking forward to working with communities across multiple sectors. Of course, at the foundation level, it's going to be to make sure that we can develop and mature these technologies to serve various application sectors. In the meantime, we're going to work with leaders in the in the application tech sectors, for example, in sense and control, mixed reality, streaming, and also the use of these applications in various sectors such as agriculture, education, transportation, and other areas. So we are still at the early phase of the project at this point, but we have started working with various stakeholders in understand the needs. And also we have actually started recently, we had actually finished one training workshop or kind of user workshop recently that can be found from some of the materials can be found in the project website. In the coming years, we look forward to work with various partners and think about how we can use ARA as a platform to drive research, education, and innovation. And very much look forward to work with folks in this workshop if you may be interested. Yeah, so that's I guess what I have as a high-level overview, and more information about the project can be found from the website, and I'd be happy to answer any questions you may have later.
Yeah, this is Garland McCoy. I was just wondering, since I'm working on the mobile methodology by virtue of the FCC requesting challenge and validation. It's an open call for proposals in the mobile space. But one of my concerns has been all along is the capture of all the spectrum that's being utilized in any particular area. And so going beyond, for example, what can be captured by an unlocked smartphone in terms of all the license carriers in a particular area, and of course the two Wi-Fi frequencies. So something that's going to capture all the something a la Stingray or what's the Hailstorm, the latest update of that, that's going to take all the frequencies and tell you, because I think you're going to be surprised at some of the stuff that's being used in any given area that you won't pick up without this type of equipment. I was wondering if that was on your radar.
So if I hear you right, so the question is about how to is it related to spectrum sensing, like knowing what's already there so that you can identify spectrum to use? What is this about? Spectrum availability in the rural regions in general.
It's about all spectrum. It's about, in other words, it's dealing with unlicensed, licensed. What at any given place, particularly in rural America, where they're starting to experiment a lot with white spaces and low raw WAM and the 6 is coming in that they got from the electric utilities, and some other frequencies that where a lot of experimentation is going on, and you can learn a lot about what's going on. A good friend of mine in Pennsylvania who's on the broadband, who's on the Precision Ag task force. He began his career before he got into agriculture as a broadcast engineer, and because he knows what he's doing, he managed to identify the two mobile robust mobile spectrum that's being used, that's going across his farm. He contacted them, was able to utilize both of them from 2 different carriers, but bring them both together, and he now has a very robust broadband for his farm. But only because he knew that these 2 carriers, licensed carriers, this is all licensed, were going on over top of his farm.
Mm-hmm, mm-hmm.
So
yeah. Yeah, so I guess if I hear you right, I think there's I guess one question is, if I'm a farmer somewhere, how do I know what service is around me, right? So that I can type into that. I think that's probably some of the problems that have been looked at by other colleagues in the actually supercluster. I know Robert has, that's actually one of the questions Robert has looked at. I guess there's also the other aspect of the question, right? Do we have all the technology that should be there? It should be there to make broadband, rural broadband as affordable, and also having the same quality that we enjoy in urban settings. I think the answer today is actually still no, right? I think there's a still technology gap that need to be filled. I think that's one of the mission for this effort. And then there's also the general spectrum availability, because from what my experience of working with the rural telcos, especially the smaller rural telcos, for example, in Iowa, we have over 130 small telcos just in our state. So one reason they have not invested heavily on wireless solutions because of the concern of lack of access to spectrum. Right? So there's innovation that's going to be needed to make spectrum available to the rural areas, to the rural telcos, to address some of these issues. Yeah.
Great, thank you very much. Jiri Power with i3, you'd spend a little bit of time telling us about what you're doing and some of your perspectives.
I'm Jiri Power. I'm CEO of i3 Systems, and I'm also a founder of the i3 Consortium. i3 Systems is a startup, and we support real-time data networks that span organizational or geographic boundaries. We largely focus on data governance issues and how do you build complex networks as the number of data streams continues to increase. And that means we put a lot of focus on privacy, trust, and incentive mechanisms as enablers of sort of an ongoing, a sustainable data system. Somebody at one time compared, as with someone from the United Farm Workers, they actually thought about what we were doing, and they said, it's kind of like a grain silo, but applied to the data industry, in that the idea in a community grain silo was that it was a utility that was there for lots of farmers to use, to make things common and share some costs. And that's kind of what we're doing. If you start thinking of all these data streams in ag tech, how do independent farmers sort of work together on collaborative issues? So i3 actually traces its roots back to the work of the i3 Consortium. It was a group that we formed when I was at USC in 2017, and we joined GCTC in 2018. The i3 Consortium it's a GCTC regional cluster. Regional clusters in our sort of area groups that are focused on specific topics. While I could talk for a long time about the consortium or about i3 Systems, I've been asked sort of to represent the GCTC regional clusters and what that is. So let me just talk in general about regional clusters for a minute. So regional clusters are different than superclusters. There is some overlap between them, but superclusters tend to be focused more on technology and applications, where the regional clusters tend to be more focused on proof of concept and operational issues. Ideally, there's a pretty strong feedback mechanism between the regional clusters and some of the superclusters, and then the superclusters reach out and actually should be interfacing with a number of the regional clusters as well. So you have this feedback loop where someone's developing the technology, the ideas, and then when we go to deploy it and think about how do we run it in an operational setting, those tend to be the kind of issues where the regional clusters step in. I put on I've only got the one slide because I've asked to sort of keep things moving. So there are some principal organizations that sort of help put this idea of regional and smart clusters together. There is a set of examples there of some of the regional clusters that are active inside the GCTC. I will note, like Raimundo, he was presenting just before you guys broke for you grabbed your lunch. And with Coral Gables, Raimundo represents sort of a regional cluster in the South Florida area. I3 Consortium represents kind of what we're doing in SoCal, and the I3 Systems is really just a member of that consortium. The whole goal in all of this is we start thinking about these things is too often the work that's done in smart ag or smart anything, it sometimes tends to remain in silos and not be shared with people who might reuse exactly what we're doing, or maybe do some concept stealing where somebody says, hey, this group, this regional group, this supercluster figured this out in this context, let's try and apply it to a different context. So this is an idea sort of to elevate the conversation and to get people interacting more and trying to proceed more as a community of people interested in this technology rather than a bunch of individual data points.
Well, thank you very much for having me here. My name is Jiri Skopek, and I represent the Smart Building Supercluster. We are a group of subject matter experts who are dealing with smart buildings and communities. We have been focusing recently on some of the issues of smart buildings and communities in post-pandemic era, and specifically on two critical issues we see, which is the response to the COVID-19 and the role of smart buildings in decarbonization. First of all, the response to the COVID, while we're having great success with some of the vaccinations, we still have the increase of some of the variants, the Delta variants, and so we are not completely out of the woods. And so the response to COVID is still a concern, and it affects the way we work and the way we actually use buildings and we use the space. The other aspect is the climate change. We know we need to decarbonize, but at least by 2050 at the very latest. And we see all these events around us, whether it's the heat dome, the drought, the hurricanes, the floods, the sea rise, the fires, and these are increasing rapidly. So we need to do something about it. So those are some of our main concerns. And we certainly have seen the impact COVID had on the land use and the building use. We have seen a migration from the cities to rural areas, to small towns, mainly caused by the social distancing, the need for the social distancing. We have also seen some, actually, for some people, positive aspects, the potential to work from home. And there is still some statistic which say probably 30% of the people will stay at home, which actually had a great impact on the use of the internet. The negative aspects of that, or you can see negative, is the increase of energy. The data centers, the servers, particularly the streaming, cause energy hogs, and we've seen about 9% of the increase in energy consumption, which has the subsequent emissions. So, if we try to reconcile the decarbonization, the reduction of the emission, we still have a job to do. What are we going to do about these servers? And certainly renewables are sort of one possible answer. So how do we actually decarbonize the buildings, which is our main subject? There's a couple of things obviously we have to do. We have to improve the building envelope, the heating and cooling system, the operational procedures, and we have to bring the renewables and clean up the grid. Now, how are we going to do that? We also have to make the buildings responsive to the grid signals and vice versa, and have the buildings talking to each other and to the grid, which will mean to have grid-enabled buildings. So when we were kind of thinking about it, we kind of put these things into 4 different buckets. First of all, is the creating robust economies using smart technology. You have to view everything through economic lens to make kind of economic sense and make it profitable and so on. Then we have a looking at applying the smart technology for health, security, resilience. How do we decarbonize the buildings using the smart technology? And finally, the smart infrastructure, which will be again critical to the whole decarbonization aspects as well. So how do we actually use the smart technology to create robust economy? One thing we see, virtually every city or region is now talking about smart building or smart regions, and there are very good reasons for that. Because the technology is typically the driving force of any economy. And the places which would fail to become smart will probably lack in the economic development. Our group has come up with some interesting case study. For example, San Leandro, where an owner of a large local business, in fact, the person who developed the PI software, saw some real estate opportunity along the line of the fiber. And he started to develop the type of buildings which now are bringing people and businesses to San Leandro. And this is leading to the revival of the city. Very much like the presentation on the Independence this morning, which was kind of illustrating similar case. So obviously this is true. It's actually not totally dissimilar what was happening at the turn of the century, where people were developing along the railways, or in the 50s, where people were developing real estate along the interstates. So, we see where the broadband goes, there are the economic opportunities, and that certainly applies to rural areas as well. So the other bucket we were looking at is the health, safety, and resilience. And the resilience probably would be subject of its own. So I'll move on. Part of our group was engaged in a project on the West Coast, where they did an assessment of county offices for safe work return. How can people get back to the offices? And certainly there's a tremendous opportunity for applying smart technology to things like detection of temperatures, the access controls, the detection of the densities, to know how many people there are in room, which is actually also critical to the building operations, how much ventilation those different spaces in a building need. So you provide for the health, but also you can save energy at the same time. So the technology certainly play a big part in ensuring health. We've seen great increase in telehealth, and which also applies to the rural areas. So very much a subject on people's mind where the technology can contribute a great deal. So our group is also focused on the smart buildings. And the question is, what do we mean by smart buildings? There are many definitions of the smart buildings, but we see the smart buildings as buildings which use technology to respond to the needs of people. We were working with the Telecommunication Industry Association on smart building standard, and exploring the components of the smart buildings. And you can see these different layers which define the smart buildings, which are the building services, the power and energy, connectivity and telecommunications, building subsistence and operations, and finally the analytics and intelligence, which actually combine to provide the value, which are the main drivers of the smart buildings, such as the economic development, productivity, sustainability, and so on. We believe in the next few years, there's going to be tremendous need to retrofit building to achieve better energy efficiency and to meet the goal of the net zero. And there are many operational aspects of the buildings which are low cost, no cost, but obviously there will be some capital expenses such as mechanical systems and improvements to the building envelope. The good news is that this will actually provide jobs. So there's a good news on that score as well. And finally, I mentioned the infrastructure. One thing we've seen in the COVID was the need for healthy cities and more nature in the city, so people can disperse, they can go out and enjoy the fresh air. We also seen a need for adaptable networks where people can connect through Zoom, but also find shared workplaces or hybrid workplaces. To manage the dynamic buildings, we will also and provide the type of ventilation which will be needed. We will need these buildings to be smart and also grid interactive. So they can respond to these various things I was talking about. We actually now have some good examples of grid-enabled buildings. This is a South Landing in Spokane, which is a building which does have storage batteries and can charge during the night, which is low cost electricity, and then discharge during the day, whereas the peaking of the demand. So that's a very good example of how some of these buildings can be converted or developed to start to be grid connected and communicate with the grid. It doesn't have to be limited to the cities. We can have energy agro communities with renewable projects. And this is a great opportunity, particularly in rural areas, which actually brings me to the smart grid. We will need to have a smart grid to accept the renewables, but also include things like storage, microgrid, and the grid connected buildings. And so the smart grid actually can consist of these smaller fractal grid, which are then connected to the bigger grid. And that will protect us from some of the climate change problems like we've seen recently in Texas, where the grid was disabled for a while. And that will kind of give us better resiliency. That in probably next 10 years, we will need big restructuring of our electricity infrastructure to create these type of new grids. So the electricity is one thing, but certainly in more northern climates, the heat is paramount requirement. And so we will need some thermal storage as well as energy exchange. One of the good things is that different buildings have a different heating profile. So for example, the offices need heat during the day, whereas the multi-residential buildings need the heat during the night. So if you can actually start transferring the heat from the buildings which have a surplus of energy into the buildings which have a demand for energy, you can achieve tremendous efficiencies and again save on the emissions. So if we kind of put all of that together, we can have a truly resilient, energy resilient city. But hopefully it will not be just for the energy, because we need resiliencies for water with all the drought out west. It starts to be critical. We also need to deal with waste and transport to have a truly sustainable city. So these are some really exciting challenges, but the time is running out. And we've got to do it now if we're going to stop what will be an unprecedented global catastrophe. So thank you for your attention, and hopefully some of your work will help us to reach these goals. Thank you.
But one of the things that was mentioned was the difference between the regional clusters and the superclusters, one being focused on the technology, the other being focused on proof of concept. when we're talking about driving some sort of a program for proof of concept in a rural area, what are the challenges that you would foresee in putting together the resources to grant that sort of experiment in a small community or in a regional constellation of small communities, as opposed to a larger city where you might have a greater sample set to test that case, but from which you might not be able to develop the particular impacts that you would want to know about for a rural area?
One of the things when we talk about rural, we need to separate into, because maybe there's more than two buckets, but in my mind, at least, I separate them into two buckets. One where we're talking about rural as being a collection of family farms, small farms, but where there's lots of individual entities that are independent but want to cooperate together using their data for the betterment of the community. The other bucket that is also rural, I think about big ag and these massive farms that are out there, or massive conglomerates that sort of drive things, and I think we have to look at those two environments as being different. So how they cooperate, what they do, there's really some differences sort of as you start to approach and say, all right, how do we even characterize the problem? Because it becomes very different in both of those environments.
Yeah, I would definitely agree. I mean, you know, we've been having tremendous increase of what do we call the Metropolis? You know, there's a almost, you know, particularly on the East Coast, we have a kind of a continuous Metropolis, you know, going from Boston all the way down to Florida, pretty much. And it's a kind of a mixture of urban and rural. So, you know, the distinction is not that great, but what Jerry's kind of referring is more kind of these super farms, you know, out west and Midwest, which kind of do need a different approach. But you know, I think it's what's kind of interesting is how the infrastructure could tie some of these things together. You know, in fact, you know, the railways kind of connected the country. And the railways are still there, and you know, people still kind of talk about some resurgence of the railways. So you know, why not stretch some of and you have lots of the small communities, even agricultural communities along the railways. You know, so would that be an opportunity to combine resurgence of some of that kind of infrastructure with the cable? I mean, there are various opportunities.
Yes.
Hey, this is Joe Sawaski from Merit Network, and I wanted to say hello to my old friend Hongwei. We used to work together at Wayne State University in Detroit when I was the CIO there. I hope you're doing well. Question for you, Hongwei. How have you leveraged your experience in urban settings to the rural settings that you're now working in? You've gone from one extreme to the other, and I'm really curious how you're leveraging that experience.
Yeah, great to hear from you. See you, Joe here. Yeah, so to me, I think, you know, on the topic broadband and connectivity, right? What we used to see challenges and opportunities in Detroit. I think there are similar challenges and opportunities in the rural Iowa. And in fact, I think as we look at broadband and then US leadership in innovation in broadband in general, we want to actually keep both words in mind, because that's actually what's needed to drive the innovation forward. And if I may also take this opportunity to respond to Josh's comment, a note there, I feel, you know, I'm a kind of a professor, try to learn, you know, work with communities through some of this project. One thing I notice is that there's a tremendous value of kind of think about how we can align the thinking methodology and strategies across different stakeholders in the region. In particular, you know, from the university's perspective, how we can align some of the kind of ivory tower type of research with what community would care in the near term, and also align some of the long-term strategy and interest of various stakeholders. That's going to be key. And in the context of this workshop, right, I think, you know, broadband, I felt we have been talking a lot about broadband for the past decades, right? As services that need to be enabled in the rural regions. But I think it's about time to think of beyond that. Actually, can we leverage broadband as an economic driver itself, not just as a infrastructure to drive other industries? So that would be I think good question to look at, because especially if you want to look at this in the context of the fast iteration of technologies and the fact that when technology was first developed, they may not always focus on the rural, right? I think there's actually an opportunity for the rural communities to step up and find strategies to actually shape the technology evolution that's also have impact on the urban regions too, because there are actually many of the advanced technologies and applications can be best tried out in the rural regions before you do it in the urban settings too.
So to come back to build on that point and go back to Jiri's point, I think the idea of building broadband on the railroads is like a really interesting one. That certainly gets broadband in more places than it's been before. Certainly, I think the broadband infrastructure bill, assuming that somehow makes its way to being successful, hopefully that'll put broadband out in even more places in rural areas. But a lot of times when you think about broadband, I mean, they're sort of targeting humans. Where are people? How do you get education to them so they can learn about technologies? That's all like super, super important. But I think when we're talking ag, we also have to think about how do we get basic communications out to the middle of a field where there's nobody who wants to be, nobody there permanently who wants to be accessing the broadband network, but they still have connectivity needs. So I think that's an issue. We almost have to sort of think about connectivity as sort of a tiered issue. So I think that's good. I think we also have to be thinking too, though, about if you go back to the big farms, I mean, those are people that have IT staff, whereas smaller farms, you don't have that. So the operational approach, what's considered user-friendly, from how do you get it so people can easily pick up and use these things, it becomes a very different question in those two environments. And we've got to think through all those things and come up with solutions and not just assume there's this generic rural solution that can be applied across everything, but we got to think about how do we build it so that it can sustain itself over the long term.
There was an article in the Wall Street Journal a week or two ago that spoke about the migration out of big cities into suburban and rural areas, and that wave is carrying some tech entrepreneurs with it. And the commentary was that so long as the tech entrepreneurs were located in Silicon Valley and the big cities, a lot of the developments tended to produce more photo sharing apps. But once we bring entrepreneurs who by nature are curious and are problem solvers out to rural America, they're going to confront problems that they didn't see in the big city. And their natural tendencies to confront and solve that problem is going to result in a technical revolution that suddenly sees us applying IoT and broadband-enabled technology to look at peculiarly rural issues and to change the game there.